Hello everyone. In today's session, we would like to share the evolving paths of Tencent data center infrastructure. We would like to cover three major sections. First is the overview about the Tencent infrastructure from year 2008. Next, we will talk about the details about Tmdc design, which is approved as OCP contribution, and the related specification could be found at OCP portal now. In last, we will cover the next generation Tencent data center design, T-block series. Tencent owns the largest data center installation in Asia Pacific. We own more than 50 data centers around the world. Refer to the picture on the right side. There are three major data center groups in China to service countrywide users, and they are located at 10 core cities. All of them are top-tier cities in China. More than 1 million servers were deployed in our data center since early 2019, 100 terabyte plus internet bandwidth, and TV level interconnection between data centers. Here is an overview about our data center scale. Tencent data center team started infrastructure prototype and design since 2008, and this page presents the key words, technology introduced by year and phase. 240 watts high voltage DC is China specific, and we did fully validation with more than 1 million amps installation base from 2008 to 2010. Tmdc is next focus between 2011 and 2012. We deployed 100K racks in production. Normandy platform support our third generation data center technology to achieve more efficient PUE, average less than 1.3. Normandy model, I would like to explain a little bit. This is Tencent specific terminology and applies to our third generation best practice architecture model for power and cooling technology. From 2015, indirect evaporative cooling was applied into our infrastructure and be part of our deployment standard. Now we are moving to the direction of T-block level design and campus deploy model. This is target for fast enablement for hyperscale demanding. Starting with the modularity, making standard with full pilot, enable supply chain with productivity. These are general logical to drive our technology development. Here are the list about our fourth generation of the Tencent data centers. Fourth generation, definitely, these are legacy deployments with UPS and raised floor structure. Average PUE is around 1.6, no surprise, right? Second generation is our self-built facility in Tianjin as a reference. We introduce water side and fan wall free cooling. New power model with hybrid high voltage DC and AC. AC is direct grid power to system, and we achieve PUE with 1.4. Third generation is TMDC and a Normandy model. In this generation, we reach PUE with 1.3. Fourth generation is our latest deployment is T-block and T-base model, which could make PUE lower than 1.2. Now I will talk about the TMD details. Here are steps to enable one data center around our cities with Tmdc. First step is to construct multi-layer buildings. Next step is to install the power grid and the water pipelines. Third step is to install the prefabricated Tmdc by room, by building. Step 4, we will scale with copy-paste model, and the total order to build cycle is around 3 months. So that's the way we go ahead for fast delivery and with flexibility. In a long period, the capacity of data center available from our partners vary a lot by tier. This is one of the reasons why we introduced Tmdc, right granularity to fit with different tier of data center around China, large, middle, medium size, and small size, and different by regions, right? We have already deployed 5,000 Tmdc and up to 100K rack wall volume so far. Here, I would like to mention about 240 wall high voltage DC, which is adapted in China widely, used as key parts in our power solution. Definitely, Tmdc also could offer the dual AC solution with UPS. Tmdc and the Normandy model is Tencent best practice by years operation experience. It includes quite a few key components following: predefined IT racks aligned with certain power budget, mechanical frame structure with cold eye containment, high efficient in-row precision cooling with wide industry supply chain, dual AC with high efficient UPS, or high AC plus high voltage DC power options, standard module level northbound management interface. Tmdc enables a lot of advantages like disaggregation between IT equipment and the data infrastructure, flexible for scale and configuration, built by stage and demands, short to build cycle, and a cost advantage with mature industry supply chain. This is a picture about one of the typical campus with Tencent TMDC deployed. The whole campus is composed of multiple 2-layer buildings. Each building is equipped with dual 10 kV imports and capable for 10 megawatt budget, offering installation for 20K to 25K server installation base. This chart presents monthly Tmdc PUE with more than 12-month cycle. Highest PUE happened at August with 1.38, and the lowest PUE is 1.17 at 2nd January. Here's one interesting point if you notice it. The 2nd January is better than the 1st January because we introduced free cooling technology here. Environment temperature is one of the key facts over the model of heat exchange, and for the cooling efficiency a lot. Additionally, Some other key points contribute for the improvements. Power architecture with high voltage DC and AC utility power direct model. Customized cooling control policy aligned with our IT loading. Well sealed frame structure to minimize the leakage of airflow. Here are a few TMDC design highlights. It's fully standardized package. We just pack everything as a standardized product and split from the building facility. And we have different capacity module is available. For example, like 18 racks or 12 racks for different density. Second is modularized. We have adapted the common commercial module and parts, standard and flexible for configuration. No UPS. We supply the utility power to serve directly, and high voltage DC could be backup or load sharing model. The power efficiency is over 97%. In-row cooling. This could shorten the airflow distance, improve the cooling efficiency. It's fully productized because we have did the prefabrication and fabrication and tested, and very easy for on-site assembly. Deployment definitely is fully independent, and due to its granularity, it could be hot pluggable and replace and rework. Here is a typical configuration of R18 modules. Contain 18 racks, that's why R18 comes from. It is equipped with UPS, battery, air conditioning, CDU. All those standard components could be shipped to room via the building elevator and easy for on-site assembly. The height of the base structure is 40 cm high, used for deployment of the kilowatt pipelines. Battery unit and the CDU are 800 mm width, and all other components are standard 600 width. The detailed layout about the base structure is at the right hand side. And you also could refer to our online documentation for more details. We offer and validated 5 models of TMDC and offering different cooling capacity and IT volume. Up to 120 kilowatt to 130 kilowatt power capacity per module, and per rack budget varied by the rack quantity. Be aware, the cooling capacity is the key points. Actually, the power capacity is not a limitation. If you would like to have more information about the cooling and those parameters, you could go to the OCP portal and find out our specifications there. Benefit from standardized products. Management interface of TMDC could be unified. This simplifies our resource investment and enable further operation automation at different levels: rack, module, building, UPS, and campus. It makes possible that we have better precision control and consistent control over our operations. Related northbound management phase of TMDC will be contributed to OCP soon. Here is the architecture view about our Modular system, which is our automation operation platform. include 4 key components. DCIM is for base infrastructure and component management. DCOM is to streamline the operation over infrastructure. DCRM represents the resource utilization and status at the capacity level. It's very key for our future capacity planning. DCSM provides a service-oriented portal for tiered users, for data center team and for external. Here are a few pictures we have been quoted from our portal. You can see some kind of data center infrastructure thermal pictures has been used, right, for hotspot detection, and we could get the utilization, how many racks has been deployed, which has been used, how many racks has been spare, and how many racks have been installed. And here's a picture about our Nebula system to get resource view at country top level. Here I also would like to share our liquid cooling experience in TMDC. We started liquid cooling pilot since 2008 and almost running for 2 years until now. This picture comes from one of the liquid cooling equipped TMDC. Minor rework effort is executed to enable the liquid cooling. Leverage the base structure of TMDC for the installation of second loop for rack level liquid supply and return. To customize the CDU is capable for support 120 kilowatt cooling capacity each, powered by the primary loop by 46 kilowatt, and they are connected to the same second loop, so they can provide 1+1 redundancy. First picture is a rear view of the service, and you could find key components for liquid cooling. The manifold for liquid distribution inside the rack, and the quick disconnect between server and manifold for the supply and return. Second picture is about the secondary loop pipes. So the liquid pipe for supply to rack and a return to CDU. Different parts could be observed there. Dark soft pipe is CDU to loop connection. Slim stainless steel pipe is rack to loop connection. Multiple valve, liquid detection cables, and it rack. By the way, for this liquid implementation, at the server side, we use cold plate technology. Okay, TMDC is mature implementation by years. As driven by tremendous demands of Tencent Cloud, we are moving to next step, and I will introduce our next solution, T-Block and T-Base. I think everyone knows Legao, right? It's a line of plastic construction toys and building something with plastic bricks or gears. We leverage the same logic to drive next generation data center infrastructure, T-Block and T-Base, targeted for more fast and scale level deployment from TMDC. Box level design with different type of modules, IT module, power module, cooling module. Just for a simple illustration, one IT module plus one power module and one cooling module. This assembly is a base unit for deployment. Cooling solution is one of the key differences from TMDC. Right? In TMDC, we use the in-row cooling. Now we are using something different. One block is composed of multiple boxes and up to the available space. Then one building could contain quite a few blocks. Finally, campus level deployment is approached by different buildings. All those box level modules are prefabricated and tested at factory and shipped on-site for quick assembly. Here is a reference picture about our T-based campus built from T-block model. Instead of limited space around Tier 1 cities, low-tier cities or West region of China offer more space with low cost. This enables us to build warehouse-level infrastructure with flat style instead of multi-layers, right? This is typical flat warehouse design we adapt now. Besides of the flat warehouse design, we also enable multi-layer facility design. With high-rise structure, we could achieve more IT racks from those top-tier cities where constrained land space only. Here is the top view layout of our reference building, composed by 4 large blocks. Cooling modules are equipped with according IT blocks at the building site. UPS systems are located at middle horizontal lane of the building. It's in red. Middle vertical lane is used for data center operation zone. IT module, power module, cooling module have different predefined SKUs, and they are assembled by ratio for block level target. Power module and heat exchange module has been rebuilt. We introduced indirect evaporative cooling and no chiller and standardized prototypes. And for power and heat exchange, it's N+1 assembly introduced and easy for maintenance. No air containment by heat exchange, and we introduce more free cooling and bed PoE could be achieved. Pay as you go, it could be scaled by box. For power module, we still use AC and 240 high-volt DC. This is very mature usage and deployment. So the total PoE could be achieved less than 1.2 at most of the place. Besides of the T block, we also enable the mini T block. So it's quite easy to be understand. It's not large size design, it's a mini design. It's only like 4 or 8 racks and all-in-one design with power and cooling. Only 45 days delivery time. The target application scenario and a huge model is for edge computing, for small private cloud, 5G IoT base station. So those are very oriented, huge model. Now I would like to introduce a little bit more about mini T blocks. Look at this picture. It is very standard ISO 20-inch or 14-inch containers with IP55 enabled for the waterproof and outdoor user model. It has dual power feed with AC AC or AC plus DC enabled, up to 8 racks, and normally that we could provide 13.2 kilowatt per rack budget, and also the maximum per rack power budget could be 20. Indirect evaporative cooling has been used, and also we could use mechanical cooling as backup solution, and all the required systems and components for the security, operation, management, and safety has been installed. From cloud to edge is one of the hot topics for this OCP summit. I saw quite a few sessions with same topic. I must agree, from cloud to edge is also applied to our mini T block very well. As ramping up of 5G deployment, edge computing and the related infrastructure become hot spot for investigation. That's why mini T block comes. Mini T block provides suitable form factor and a power envelope to support required computing horsepower for edge and private cloud. Here is potential reference architecture based on mini T block by Tencent Cloud. Install with Edge Connect, that software stacks to enable interlock with telco UPF to support customized 5G data routing to our mini T block. And we also install the edge computing platform to enable ICE and PaaS service for accelerated processing over incoming 5G data stream. So this could be used for the robotics control, could be used for the cloud gaming. The mini T block could be at the 5G access layer data center or aggregation layer data center with adding a few more mini T blocks as bundle. So here is a reference case in our source. This is video recording, so we could not go ahead with QA session. If you have any question or comments, feel free to reach me by ansellee@tencent.com. That's all for my today's topic, and I'm looking forward to open collaboration. Have a good day. Thanks.